Now we are going to see PN junction characteristics. We have already discussed biasing, forward bias, reverse bias. Now we are going to see characteristics of a PN junction diode. Diode characteristics. The figure shows the PN diode, schematic diagram of a PN diode and PN junction diode characteristics. Here forward bias characteristics and the reverse bias characteristics. First we are going to see the forward bias characteristics. A graph between forward voltage and forward current is called forward bias. A graph between reverse voltage and the reverse current is called reverse characteristics. The figure shows the entire forward characteristics and reverse characteristics of a PN diode. Forward bias or forward characteristics. The diode is connected in the forward biasing mode. That is, P type is connected to positive terminal of the battery, N type is connected to the negative terminal of the battery. Once the connection is made, the depletion layer decreases. See, origin up to 0.7 volt for silicon and 0.3 volt for germanium. That will be very minimum current. Once this voltage occurs, that is, once this voltage reaches, that is 0.7 or 0.3, further increase in the supply voltage, the current increases in the order of milliamperes. The current increases. That current increases. This portion is called an exponential region and this is a linear region. Here we are going to take a resistance. So that is del V by del I. The resistance value is minimum. The reverse bias characteristics. The anode is connected to negative of the battery. Cathode is connected to positive of the battery. Once the connection is made, the depletion layer width increases. Only minority carrier current flows across the junction. From this point, the reverse current is very minimum. Once the supply voltage increases, at the reverse breakdown voltage, the Zener breakdown or avalanche region occurs. Here from this, the resistance value, from the slope, we can find out the resistance and the reverse bias condition. Del V by del I, the resistance is very high in the order of mega ohms. So the reverse bias state is close to the switch, open switch state, and the forward bias state is a close to the switch state. So this forward bias state is called on state of the diode. Reverse bias state is the off state or open switch. Now we are going to see practical diode. Some practical diodes are 1N4000 series. Here the N represents the junction. That is, 1N means one junction device. Second, OA79 or OA80. The first letter represents the device is made of germanium, the O. The second letter represents the application of the device. Here the device is used for signal diode or communication purpose. The third one is BY126 or BY127. The B represents the device is made of silicon and the Y represents the rectifier applications. So far we have discussed diode characteristics, forward bias characteristics, reverse bias characteristics, then practical diodes. Thank you.